So next up, we have, just zooming in via video, pre-recorded, is Sam Nastase, who is currently at Princeton on his way to a new faculty position at the University of Southern California in LA. We're very happy to have him representing our group on data sharing. So there's a lot of really interesting stuff here, and we're going to let Sam share wisdom with you.
Okay, hi everybody. My name is Sam Nastase. I'll be presenting on behalf of the sharing team led by Elizabeth Dupree. Really wish I could have been there in person, but just couldn't make it this year. So I have some references and links in the slide deck here. You can find the slides on my website if you want to click through to anything or just ask one of the organizers. Okay, before I start, one quick moment for self-promotion here. So I'll be starting a lab at the University of Southern California in Los Angeles in August. I'll be recruiting grad students, maybe a postdoc this fall, winter to start in 2026. So please apply or send your best students. Okay, I think this is pretty obvious. Our science is becoming increasingly computational. This introduces new challenges for interpretation, for replication, for generalizability, and so forth. And as our science becomes increasingly data heavy, it becomes more entangled with the code and the software environment and so forth. I'm probably preaching to the choir here at OHBM, but I think the only viable solution to these kinds of challenges is openness and sharing. And the most important take home when it comes to sharing is that we need to provision our experiments for sharing from the start, not as an afterthought. Without sufficient standardization, without enough metadata, open data, become effectively unusable. In this presentation, though, I'll focus on a particular aspect of sharing, that is the special considerations for sharing in naturalistic neuroimaging. So naturalistic neuroimaging introduces some particular challenges for sharing, but I also think it has incredible promise. I would argue that sharing is basically a necessity in naturalistic neuroimaging, and the value of sharing is so much greater for naturalistic studies than for traditional non-naturalistic experiments. So what's so special about sharing in naturalistic neuroscience? Naturalistic neuroimaging data are intrinsically rich and sort of multidimensional, so there's incredible mileage there in terms of reuse. Naturalistic data sets can also support a number of different scientific questions, right? So there's many latent hypotheses in the data sets themselves. This is in stark contrast to many typical, controlled experiments. In that kind of setting, we typically want to manufacture experimental data to test a particular question. We're going to try to rule everything else out. So in this sense, I think naturalistic paradigms are very similar to resting state data, but I would argue even richer because now we can also quantify the stimulus in a variety of ways, and I'll get to that in a moment. I also think it's really critical for our field to kind of move toward community benchmark data sets, running models up against community benchmarks. That can really accelerate research. I think naturalistic data sets are perfect for that kind of thing. We've seen the power of that in machine learning, for example. Okay, there are challenges here, however. Naturalistic data are super closely entangled with the stimulus itself. This, on the other hand, is very unlike resting state data, where there is no stimulus to worry about. And as people push the frontier of naturalistic, we also start to run into problems of sensitivity, for example. You might have recordings of people's speech or recordings of their facial expressions. And as you go more and more natural, you end up picking up parts of people's actual lives, right? So in Uri Hassan's lab here, we have a data set where we're recording 24/7 ECOG and all of the speech in the hospital room while patients are in the epilepsy clinic for days or even like a week at a time. These are incredible data for modeling like language in the brain, for example, but these people are talking with their doctor, they're talking with their family and so forth. So as we go toward more real world data, the data become intrinsically sensitive. And so we don't have all the solutions for this yet. That's kind of what we're trying to work on here. But I would say our current recommendations are to, obviously use BIDS and OpenNeuro when possible. Try to provision for sharing as early as possible using things like the open brain consent, using tools like ReproIn, for example, to more easily BIDSify your data. And ultimately, we want to be able to take data like this and the stimuli and incorporate them into tools like NeuroScout. This obviously doesn't cover all of the cases. We'll still need to keep working on solutions, keep working on those BIDS extensions and so forth. Okay, now I want to move to the second component here, a critical aspect of sharing in naturalistic neuroscience, which is sharing the stimuli themselves. So I think naturalistic stimuli can be as rich and as interesting as the corresponding neuroimaging data. We can extract all sorts of different features from a naturalistic stimulus. We can sort of formalize particular hypotheses as models and run these models up against the data. And as new models emerge, we can sort of try them out next. So for example, we might be able to crowdsource human annotations for an existing naturalistic data set. We might be able to collect, for example, eye tracking data with this particular movie. A lot of the work that I've been doing, we take our naturalistic stimulus and we run a neural network model up against that stimulus. Then we go into the neural network, extract those internal representations, and try to map those onto brain activity. So again, a lot of mileage there, but also challenges. For example, many of the naturalistic data sets that we have are based on commercial Hollywood-style movies, right, where sharing is going to be restricted by copyright. And it's a real fundamental challenge of how to organize all of the metadata, all of those model features, stimulus annotations, and so forth, in a way that people can actually understand what's going on and people can use it. And that just gets more difficult as the number of features increases, the amount of data explodes, right? Folks like Alejandro in our group are actively working on this kind of problem. So again, some current recommendations would be to see if there are non-copyrighted stimuli that you could use, right? There are stimuli specifically created for neuroimaging like Inscape, so there are databases of stimuli that you can sort of easily share. We're working on building explicit recommendations for providing all of the information someone would need to kind of recreate your stimulus, so exactly the movie file and how it was played with what particular timing, and we can try to wrap all of that up into a BID style JSON format. Okay, I want to motivate all of this with a particular example. This is just one of the earliest and really stellar examples of the power of this whole process. So this was the paper on this was in 2014, so over a decade ago, and that's the study forest data set. I think there are 60 plus studies that have already grown out of just this one particular open data set. And there's this incredible little community of people contributing to expanding the data set. So I want to let me show you the website here. I really recommend checking this out. I mean, it's a beautiful thing that they've set up here. I wanted to show you mostly the data here, right? So they started with a fMRI movie acquisition, right? But then added all sorts of other components to that, right? Like different imaging parameters. They have retinotopy, they have visual localizers, and so forth. Different kinds of structural imaging here. And what I think is most exciting is all of these different annotations of the movie stimulus itself, right? And other groups coming in and contributing annotations of like the camera cuts, the sort of locations that the different parts of the movie are, speech transcripts, the emotions, the semantic content of the movie, social content of the movie. I think it's just a beautiful example of the kind of thing we want to help people to be able to do in our working group. We want to sort of provide the infrastructure, provide the recommendations so that you could collect a naturalistic data set and really let it run wild like this, really build it up in this way. Okay, the last slide I have here is our breakout project. And so what we're hoping to build on here is Elizabeth's original landscape of open naturalistic neuroimaging data sets, because many have come out since then. This is, this list is not up to date and we need to get it fully up to date. So we're hoping to get your help in crowdsourcing data sets and the different kinds of information we might need about them. You can use the QR code here on the slides to get to a Google spreadsheet where we're working on this. I think Susanna Weiss will be helping to run the sharing breakout session. And this little project here should dovetail nicely with her group's data catalog, which really takes this to the next level and kind of makes it much more interactive, brings this online and searchable and so forth. Okay, so I'll end there. I'm going to thank Tammy and Einat specifically for making all of this happen. And then thank you, everyone, for listening. Okay, bye-bye.
Very nice. Thank you to Sam from afar.